let's see how good we have gotten at trig derivatives. Leading coefficient here is 4, and that just sits. We do the derivative of what's after it, essentially. And the derivative of cosine x, we have learned, is negative sine x. Only thing you do to clean that up is put the negative and the 4 together. And ta-da, done. Here, we've got a leading coefficient of 3, so the derivative goes through that. At the outermost level, this is a sine, and so its derivative should be cosine of blah, blah, blah. Just copy that. And now the chain rule says, wait, that blah, 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 do its derivative next. What was inside the sine function, 5x squared, its derivative is going to be 2 times 5 is 10x to the 2 minus 1. And that's the end of the chain. So anytime you have, it's because we have a function sine with another function inside it. We do the outermost function and then the inside function, do the derivatives one after the other. And if we go to clean this up, we have 3 times 10 for coefficients. We have x, and then we have cosine 5x squared. The brackets are optional if no one's going to misread this. If it's clear that all of this is part of the cosine function, I'm going to put them on in this case just because that argument's a little big, and you want to make it clear that the 5 and the x and the power of 2 are all inside the cosine. If this were just cosine 5 or just cosine x, I'd consider leaving the brackets off, but in this case I feel a little better having those on there. Keeps it from being ambiguous. Okay, here is a quotient. The quotient rule tells us the derivative for this is going to be bottom times derivative of the top. Now the derivative of the top, this is squared, so its derivative is 2 sine x to the 1 times the derivative of the sine, which is cosine x. Right? So we're treating this the same way we would as if it was sine x to the second power. So 2 sine x to the 1 times the derivative of sine x. So all this is bottom d top minus, and now we have top, which is sine squared x, d bottom. The derivative of the bottom is, well, it's a cosine, so its derivative is negative sine times the derivative of its argument, which is 2. Okay, so bottom d top minus top d bottom, and all of that is over the bottom squared, which is cosine 2x all squared. Now, please tell me we can clean that up a little. We have a 2. Oh, you can tell what's going to happen here. You notice this? We have 2 sine x cosine x. They've told us over and over again, or we've seen in the workbook, that they like to turn this into sine 2x. And yeah, I think I will. I could use the space. So cosine 2x stays there. No changes to that. All this, 2 sine x cosine x, becomes sine 2x. That's the double angle formula. Minus, now can we do anything over here? We have minus times another minus, that's actually plus. We have a coefficient of 2, that can go out front. And then we have sine x squared and then a sine 2x. Sine x all squared, sine 2x. There are some weird ways to combine these sometimes, but nothing I want to get into right now, so I'm going to leave that as it is. And downstairs we have cosine 2x all squared. Again, here we have, these have a common factor, but these terms do not, so there's nothing I see here that would significantly clean this thing up. Sine 2x is a common factor. We could pull that out, but would that really be an improvement? I'm not sure. So I'd say let's call a halt right here. I was hoping to do all 5 of these in a single video, but now that I've burnt up so much space, I think I will make another one for D and E, so if you follow along to that, we'll see you in a moment.